Well, hi, good morning. Thank you for coming and joining me here in my shop. So today I hope to really sharpen up the alignment on this radio and be done with it at that point. What I did yesterday, I hoped to make it all the way through to the completing the alignment yesterday, but I got caught up in some IF finagling there, but now we're ready to go. So this is really a very straightforward process from here. I don't even need my signal generator operating to do what I'm going to be doing here. Let's just take a look at the data I collected and how I'm going to use it now. So what I did earlier, what I did yesterday, was I tuned the radio, for instance, to 6 megahertz. I then looked at the SDR to determine what the actual frequency of the local oscillator was, and I wrote that here. And the proper frequency is written here. Well, let's just turn that right around, the other way around. This is what I should see, this is what I actually got. So with the radio tuned to 6 megahertz, the local oscillator was here, pretty close, only, 5 out. That's very, very close, in fact, so this is not a big problem. So what I'm going to do today is I'm going to put it on the band with 6 megahertz, that's a shortwave band. I'm going to tune the radio until the local oscillator has this frequency. And I'm then going to adjust the local oscillator frequency using the trimmer until it shows this frequency. And I'm going to slowly move, I'm going to move each one of these to where it should be. When I do that, I'll have to realign the other elements in the radio too, the intermediate stage, antenna stage, to match. This one's not much of a change, but some of these other ones is a bit of a change, like this one. Quite a bit of a change. This one is changing a lot because I decided 9.6 was in a different place on the dial this last time around. So great, so that's what I'm going to do. Should be pretty straightforward. In fact, I'm very much hoping that this method is going to be applicable to a lot of radios. I would think any radio that comes out of the cabinet without its dial, this could be a really helpful technique to align the radio. And maybe even radios with the dial. This might be a kind of a more direct approach, I guess I could say. Okay, I'm going to get busy on that. Okay, so if you look at the chart there, at the top it says 6 megahertz, and then it says 6457, and then it says 6452. 6452 is what the local oscillator is when the radio dial is reading 6 megahertz. So I want to recreate that. Flip over to the SDR here. And here's the local oscillator frequency. And our target, I have to flip back already. We want to, I shouldn't use the word target, we want the local oscillator to be at 6452, ready for adjustment. 6452. 6452. Okay, so we want to move the local oscillator under the red line. The red line marks where the SDR tuner is set. And I'm going to tune the radio here. Move the local oscillator down there. Get it right on. Okay, so that's right on the money. Right there. Now, my objective is to put this onto the correct value, which 6457. So 6457. Not too far. What I need to do now is move this under the red line using the oscillator adjustment for 6 megacycles. And that's simply here on the shortwave band. Okay, so I'm gonna zoom in the SDR here. so I can see the difference better. And I'm just going to move the local oscillator under the red line. Okay, watching the effect of this. There's a slight effect from the metal screwdriver. Short wave. It's already over there. Yeah, I've moved quite a bit. Maybe just from me knocking into it. Because this is very, very loose. This would be one that would jump if I gave it the hammer. There we are. I got it. That's fantastic. So that's now corrected. We stick with the short wave. I might as well carry on here. Let's just see. We do both ends of the short wave. So the next one is 9.6. So if we look at the chart, 9.6. The actual value is 9863. So I want to dial up 9863. 9863. So 9863. So that puts this the right frequency. You know, the SDR actually has calibration problems, which I have not taken into account. I'm gambling the SDR is accurate, but it also has problems. So so now we want to move the local oscillator up there. It's picking something up.
How confusing.
No antenna.
Right, Dave. And Romans 13 is one passage of scripture.
There's absolutely no antenna. Here's the antenna.
This passage, so I'm hoping you can shed some light.
Now this is a very, very strong signal, I have to admit. Let's go back to lining up here. So I get this lined up. The pointer, if we had it on the dial, would be showing 9.6 exactly. Now, but that's not where I want the local oscillator to be. I really want it to be at 10.057. 10.057. 10.057. So that's where I really want the local oscillator to be. Where to go? Maybe the screen readjusted here. Let me shrink this. Did I move? Where to go? There. Okay. Bit of a journey there. Now the adjustment for that. Oscillator trimmer on gang. I laugh because I still don't understand what is going on. I'm still studying the strange capacitor in this radio. Okay, well, I'm just going to pick one of these two trimmers. The radio went very, very quiet. We are. Now what will have happened at the other frequency? Well, I've changed the other one. So let's jump down there. What was it again? Now it's this. It's adjusted here. 6457. What am I going to prove? You know what? I can't prove this. There's a weakness here in how I'm doing this. So if I tune the radio now so the local oscillator is at 6457, I no longer know for sure it's pointing at 6 megahertz. I I gotta stop for a bit and think about this. Yeah, I gotta stop and think for a bit. Now, so there is a problem with doing it the way I was doing it, but I know how to get around it now. When I did the first 6 megahertz adjustment, I should have marked the location of the bar here. I could just mark it on the side somewhere, so I can return it to that exact physical position, and then re-correct the oscillator at the low end after having adjusted the high end, because adjusting the high end probably moved the low end. And because this particular band involves adjusting the capacitor rate, like the tuning capacitor, the adjustment of this band affects all the rest. So I really need to get this right. So I think the only way I can do that is return the adjustment at the top here back to where it was, to the incorrect adjustment. Go back down, find where 6 megahertz is by looking at the local oscillator setting, mark it, and then come back up, and then do the adjustment at this end. So I have to restore this one back to the incorrect setting first. And the incorrect setting is 9863. 9863. 9863 here. 863. So I will return the local oscillator there. And this should restore anything that happened at the other end of the band. Doesn't have to be all that accurate because the difference at the other end of the band is very tiny. That's got to get it. There we are. Okay, so now if I tune down here and set the local oscillator again to the correct setting, that should mark 6 megahertz. So I have to find it on here. 6. And the proper frequency is 6457. 6457. 6457. So tune the radio now until the oscillator's on top of the red line. Never mind those other guys who were doing weird things there. Okay, now, you know, this is how errors get introduced, but I'm back where I was. This should be pointing right at 6 megahertz. I'm going to mark it. Like that. Back up to the top end. Great radio. This is one hot radio, and we are now looking for a 9863. 9863 is what we're looking for. 9863. 9863. Okay, once again, I move the local oscillator from where it is to where it should be. Wait a minute. think for a sec. What are you doing here? So, you know what's happening? I'm getting confused. I'm confusing myself. We put the local oscillator under that. Or at that frequency. And we believe the tuning is showing 9.6. The dial we're there. The local oscillator now needs to be adjusted to 10.057. 10.057. 10.057. And where to go? This is the local oscillator here, and we want it here. Okay, we'll put it there. So conceivably, this is changing the other end of things too, especially when you're moving at this kind of distance. Just go a little past. Right on. Now we'll go down to the marked spot. I put a little dot on it there. Okay. That should be 6 again. And the local oscillator will be way down here. Forgot what it's supposed to be. What's it supposed to be? It's supposed to be 6, 4, 5, 7. Let's see what it actually is. It should be 6, 4, 5, 7 and 6, 5, 9, 0. Oh my gosh, really? So what I'm going to do now is I'm going to move the slug for adjusting the I moved the wrong slug, didn't I? I did the wrong thing. Yeah, I've been in here too long already. It's only 9 o'clock in the morning. I'm already too long into this. So do we know this is on 6? Wow. You know, it should be on 6, but every time you do this, you add a little more error, a little more error. Well, what I'm going to have to do is I'm going to have to finish this and then put the thing back into the cabinet and see what happened. That's what I'm going to have to do. I'm going to have to do that. So, assuming this is the 6th spot, the local oscillator should be what it should be. You know what? There's a bigger logical problem here. As soon as I made adjustments down here, that caused the other end to adjust a little bit. As soon as the other end adjusted a little bit, my original numbers were no longer valid. When I came and set this to my original numbers, they were no longer valid. So everything I'm doing here is not valid. Everything I'm doing is going down the drain, and it's because there's 2 controls. If there's just one, I can get away with this technique. I have to stop and think more about this because it's just one step beyond. I haven't quite got a grip on the whole thing here. Gotta go away and think about it. Coffee. Yes, coffee. I need to drink some coffee here. Okay, after thinking about this a little bit, I think I really have to sort out what is going on with the capacitor, the tuning capacitor, and all of its trimmers completely, and get a complete grip on that. Number 2, I'm pretty sure when you align the first shortwave band, the alignment actions affect all the rest of the bands coming next. So if you don't get the shortwave band straight, you won't get any other ones straight either. So it's very, very important to get this correct. So I'm going to concentrate on trying to sort out what it is about this capacitor here. 3 main sections, but actually 6 sets of blades. The 3 sections, like, they all look identical too, which is another kind of a weird thing. Usually, you know, one section, the oscillator section, looks different than the other section. Pretty clear that there's a trimmer for each set of plates. So on a schematic, you'd be looking for 12 different capacitors, 12 different adjustable capacitors, 12 of them. Oh my gosh. 6 trimmers. Now, I know the one on the left of what you're looking at is the oscillator. First time through, I kind of thought the small plates were like a fine adjustment, but the more I think about that, it doesn't make any sense at all. And now I'm kind of wondering, as you switch the band switch, if you aren't selecting different sets of these. So what we're really looking at is 3 sections, but really three different sets. So you're on one band. It doesn't make sense. I don't think this makes sense. The oscillator capacitor is the same capacitor for all bands. Oh my gosh. Let's go stare at the schematic. I have been staring at it already. Yesterday, today. Let's stare some more. Just make it a little bit bigger here. So here are all the capacitors as I understand them to be. Here is one set of plates and trimmer. Here's another one here. That's 2. There's another one here. That's 3. Okay, there's another one here. That's 4 of them. There's another one here. That's 5 sets. And there has to be one more. And here it is here. Right here. There they all are. Now, the numbering scheme here, so nowhere is there a diagram that tells you which is which. But down here, if you look, for instance, look at this first 6 are all from the gang here. C1, so C1 is a large part, C2 is a small part, 28 picofarads, C3 is, they've written the word trimmer here, 2 to 10. C2, let's take a look at what C2 is doing. C2, there's C2, and I assume it's trimmer, C4. C2, and then its trimmer would be C4, trimmer. Okay, that's making sense. C2 is a small set of plates. Now it's if we go up from C2 and C4, we see it arrives at a switch. The switch isn't always selecting this, but it's almost always selecting this way. Sometimes it's selecting, let's see, here's the there's the pointer, or the moving contact, and this is the permanent contact into the ring. So whatever reaches the ring is heading to the grid. So whatever this thing contacts is heading for the grid. So here's a setting where it's just open, 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 open. What's all that about? It's possible this is the band switch, and no, it's the audio switch, this one over here, that'll turn on the phono input. Every setting is a band. Well, there's only 6 settings. Maybe the switch never gets over here or something. I don't know. Don't know what's going on there. let's just carry on. So the band that it's showing on right now, I think it's what does it say band? Wave change switch in fully anti-clockwise broadcast band. So we're in the broadcast band. So we see the broadcast band is not going through here. Broadcast band is going through these. Is that the right way to put it? So we have all these coils. All these coils are reacting with the capacitor. It's got to be this one. But if you switch up here, you're not switched into here. Oh, here, look, if you switch from here to here, you add this little capacitor. If you're up here, though, the whole time you're coming down through this guy. So this is broadcast, and it's anti-clockwise, clockwise, so this would be shortwave is here. The band I've been working on, but look, you switch to another. You know, the thing is, this is like a C9 and 14. C9 is the big part of the gang. So you're actually, when this switches over here, you're actually doing nothing with these. So you are selectively taking different parts of that tuning capacitor and utilizing it, and other parts not being utilized. Let's look at this switch somewhere else. There's more. So we look at this one. So this one's also on broadcast. So we're activating here these two guys, C1 and C3. I should almost write the numbers right on that tuning capacitor, but because I need some kind of a nicely written reference thing I can look at quickly to figure out what the heck I'm doing here. So is that really the picture then? The 3-section capacitor is only using, you know what, maybe it's using the same section all the time for the oscillator. Let's figure that out. So these are the oscillator coils, and there has to be one of those 3 big capacitors operating against these coils, in parallel with these coils. See, these wires, they actually don't go anywhere. This one does. This one, hey, from the grid, and then selecting a coil, and then selecting a capacitor. Oh my gosh. So you select different coils and different capacitors as you go, and this switch is moving too, and so is this one. And it's also selecting. These are fixed capacitors though, but sometimes they're in and sometimes they're not. These coils are drawn totally different from these. Why they do that? These are unusual coils. They're got a tap in the middle with a capacitor on it. The coil windings here have been pictured in a very special way, I'm pretty sure, to indicate something about how these windings relate to each other. You got me though as to there's no adjustment in these. L looks like 9 and 10, not adjustable. Not adjustable. Let me have the numbers wrong. 6, 7, 8, 9. That looks more like 5. L5 and 10. 5 and 10. These are not really connected together. Yeah, they're actually all these are connected between these two switches. So what's happening here is as you advance, this is one different wafers on a common shaft. So as you advance this, you're advancing you're switching both ends of these coils in and out. Likewise here. And likewise you're switching capacitors. So not all these capacitors are effective all the time. So my concerns about if you align the shortwave band and then go on to other bands, but you've messed up the shortwave band, all the other bands are going to be messed up too, may not be the case. But trying to fathom how each setting of these switches, it takes a long time to really sort out which coil, which capacitors, and that's kind of been taken care of by the order of operation when you're doing the alignment. That's why you must follow the alignment order, because successive things are dependent on predecessors, or can be dependent on predecessors. So okay, so I got a better grip now on how things are working. Let's look at this oscillator thing, and if we find the big capacitor that's related here, well, I guess maybe it's coming off of this switch, so it's going to be these or these. And why are there two more capacitors in parallel here? Like, why would they do that? Why don't they just have one capacitor here? You know why? I do know why. I already know why. The answer is one of them is a temperature compensating capacitor. And how do I know that? Because it's written down here somewhere. Negative temperature compensating capacitor, C11. C11 is right there. So it's another reason for not jumping in and changing capacitors left and right. Some of these are you'd have to have one of these to stick it in there. I mean, I don't have any temperature compensating capacitor. Wonder what that looks like. I think I know what it looks like. Okay, so we have a set here, and then we have a set here. So even the oscillator is changing. So it's not always the same main plates as you change bands. The big gets well, I mean, there's only 3 sets of plates. Now these sets are the plates and their trimmer, not big plates, small plates. Okay, what am I going to do with all this? So I figured it out to this point. There's more to figure out if I care to. Why would I bother? I think I've got a grip on the situation here. Don't know for sure if early alignment activities done wrong, mean all the rest will be wrong too, but I'm going to have to go on that assumption. Because, unless you do a lot of experimenting to find that out. In terms of where I am with this radio, I've got to put the radio back in the cabinet and verify some things again. I got to start over again. And I think part of the deal here is running a signal generator too. Okay, got to think a little more. Think more coffee. Need more coffee. Well, reading all the information over again and again, there just isn't the right connections of information here to sort things out properly. That's kind of a vague statement I've made. Here's how I'm going to solve it. So I've made a diagram of the tuning capacitor with its multiple plates and then a couple plates, multiple couple, and then all the trimmers, which I'm pretty sure that the trimmers just line up with what they're trimming. And I'm going to investigate empirically what each of these is doing as I go through the bands, try to identify which one of these is the oscillator control capacitor on each band. And I'm pretty sure it's this one all the time. I mean, that's what it would be in an ordinary radio, but I'm not so sure this is all that ordinary anymore. It's become really weird. So we'll go on. This is a long process again. So we'll go on the broadcast band here. Okay, and I need a signal to experiment with. I'm not sure noise can do it. Wow. But I don't think we're going to pick anything up here without an antenna, so I'm going to put on the signal generator here. Give it a signal, and then by playing around with the capacitor, I should be able to sort out which section is doing what in the capacitor on this band. I'll make some notes and carry on from there. Okay, so we want this on the antenna. The antenna in this case is here. That's probably going to do it. Just clipped it on the insulation here. Okay, so we're tuned up near the top of the band. Let me just bring it down a little bit. What sounds like a quiet spot? It's pretty weak. Oh my gosh, so what did I just do there? Hear the tone at 9.4. Where'd it go? 8.2. That doesn't make any sense. It does not make sense. What would make sense is if the 900 kilohertz are between these two signals. It's not 900. 8.2. 9.4. Well, I don't think it'll matter for the experiment I want to do. So I'm going to interfere with the capacitor. Maybe I can pull this around a little bit. Be careful here. Okay. Interfere with the plates and see, and I have to interfere with the stator plates. No use interfering with the. Swing this around a little further. Oh, I'm just going to switch cameras. Hey, that's even easier. Switch cameras. There we are. Okay, interfering. So these plates affect the tuning. I don't want to say that. No, that's not. That's exactly the opposite of what I wanted to say. They don't affect the tuning. They affect the signal strength. This one tuned it away. I do a little slower. It's hard to do slower. Get it to tune just a little bit. It's tuning quite a distance. Now, what about these small plates? What are they doing? They don't appear to do anything here. They don't appear to be doing anything here. They don't appear to be doing anything here. That for sure, nothing happening there. Here, I get a bigger screwdriver. Yeah, I think I'm pushing on the capacitor. Yeah. Okay. I think from that we can conclude that on the AM band we are listening to like this, AM, that broadcast band. This one and this one. So this would be, I'm just going to call it RF, and this one would be oscillator. And the impression I have is all the rest of them are doing nothing. This is doing nothing, 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 and nothing. Okay, as I go along, maybe I'll discover I'm not quite getting it right and have to do it over. Hey, that happens. that definitely happens. Okay, so now we want to go to the next band up. We want to tune in the signal. So we're somewhere, around 7 megahertz, something like that. So we'll see if we can find it here. On the wrong antenna. Let me just move this to a different wire. I'm going to connect it right on the wire this time. Turn this back. Somewhere around 7, isn't that what I thought? Okay. Experimenting time. And flexing, I have to be very careful. I think I'm flexing the plate. I'm flexing the entire capacitor. That's how sensitive this is. Just pushing the frame. And I'm not pushing it much. Well, clearly this one has an effect. This one seems to have an effect too. That's just pushing. Well, I'd say it's the same too. I would say it's the same two sets of capacitors here. What I'm gonna get with this. Okay, so shortwave looks like this again. Same thing, exactly the same thing. So on the AM band, when you go to set the oscillator, you may not be adjusting this. So like this is, you do the shortwave band first, and you make some adjustments. Then you fiddle with the AM, then you come back to the shortwave and finish it off. There's a reason why it's done like that. And I don't know what it is. I never paid attention to that, but maybe there's a hint in that in itself. Go on to the next band. Now we're at the band we're on now. Just a sec here. Too dark in the shop. 11 megahertz band. 11 megahertz band. Okay, 11 megahertz band. Can't get there from here. Okay, here we are. Repeat the experiment here. Oh, nothing. 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 Oh. Aha. So it's switched to the small capacitors. Could it be as simple as when you go to the band spread bands, you use these small guys, because it's a smaller amount of capacitance that needs to change. Yeah, those are 10 to 28 or something like that. So maybe that's the key. That's the way to understand this. If you're doing a broadband, and a broadcast band is a broadband because it has a, it almost doubles itself. Use these big capacitors to vary a lot of capacitance, but maybe on the band spread bands, you only want to vary a little bit of capacitance. So rather than move a big one a little bit, you take a small one and you move it a lot. So that means, if that's true, then the rest of these are going to be all in those small capacitors. Okay, that all kind of adds up. Kind of adds up a bit. Let's just double check now again. No effect, no effect, no effect. Effect, effect. Clearly an effect. Okay. Wow, how long have I been working on this radio, and I'm really just getting the nuts and bolts straight here. So this is the what band? It's the 20, I think 25? Is it 25? 25 meter band. 25 meter band. And in this case, we get an effect here. We get something here too. And we get the oscillator down here. Okay, so next band. What is the next band? So the next band is, I think, 19 meter band. Yes, 19 meters. 15 meters. 15 megahertz. 15. Going past it a little quick. Let's give it a little more. Give it a little more. Okay, makes sense. 15.4. Now, which U plates is ticklish this time? Nope. 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 Yep. Yep. Very much so. So it would appear that I'm correct now in how this is really operating. The other way to figure this out is to study that schematic, until there's blood coming out of your ears. Did I say 19 meter band? It's these three again. The three small guys. Okay, next band. Where are we now? And we are going to, I think, the 16 meter band, 17 megahertz, 16 meter band, 17. The radio's receiving everywhere. This is a moderate signal on an antenna. This should produce pretty good sound. This level of signal sounds that way, doesn't it? Great. And we're ready. We're ready for the capacitor check. Going to be the same thing again, I bet. I think I got it right with the learned a lesson. Yes. So it's kind of like two radios in one here, where they have a radio with a large range. That'd be the broadcast band and the shortwave band. And it relies on the big capacitor. And then when you go to these band spread, the big capacitor plate's gone and just the little plate's operating. It's like another whole, not really like another whole radio, but kind of. That's not common. It's not common. This means the other radio I've aligned, I must have booped it all up too, because it also has small plates. Okay, we're going to 21 megahertz band from here. 21 megahertz band. Start the end. 21, 21, 21. 20.4. So that was definitely the image. So in a radio like this, a shortwave radio, as you get higher and higher in frequency, and this is pretty high now, 21 megahertz, the relative distance of the IF of the I'm just going to try to come up with an easy way to understand images, but no. Okay, plate check. Let's just stay on track with what you're doing here, Jim. That's exactly what's been going on this whole time. Yes. How this now? Well, I should have figured this out right at the start, shouldn't I? What's that? What happened here? I missed a band somehow? Doesn't really matter, does it? I figured out the pattern here. I don't even have to finish this. I figured out the pattern. I've learned what I need to learn. Except the weird thing is this section here never seems to be of any use to anybody. But it must. Maybe when I go through the alignment process, I'll know which of these trimmers now to go after. Yeah, you know what I was doing? I was fiddling around with the wrong trimmers at the wrong time. You know, and it's the fault of the information I'm working from. This information is really coming up short. The radio itself doesn't even have a scale on it, so you can do this. You know, I think that story about the old engineers being upset at the young engineers is probably true. The old engineers got everything pretty good on the older model, but on this model, they seem to have left out the kinds of things you would think an inexperienced engineer would leave out, which would be all the things that involve the radio after it leaves his lab, his factory, and goes into the hands of consumers and eventually into repair shops. That's not his world, right? So maybe he just forgot totally. It's hard to believe that they could put this on the market. Surely to goodness everybody who's gone to align one of these, and if there is anybody, has anybody ever tried it? I don't even know. I don't know how many of these there are in the world. Maybe there's not that many. And maybe they don't work very well. Maybe every one of these I can get my hands on is going to be a mess. Okay. So, I'm going to stop again now that I have this new information and let it settle for a bit and decide what to do next. Wow, what a journey. Okay, I spent a little bit of time thinking about this whole situation, the journey I've been on with this radio, and what I should do next. So I think the next thing I should do is do the entire alignment procedure over again, following exactly the instructions, using a signal generator, doing everything exactly as instructed. And I'm not going to stumble over this capacitor, which I did last time around. And that's probably why when I got done and then compared the pointer with the actual dial, when I put it back in the cabinet, it was out. It was out because the alignment process I followed, well, I didn't follow the alignment process. I was confused, so I'd be turning the wrong trimmers up here at times, and just mucking the whole thing up from start to finish. So I've come to accept this about doing radios, that you know, it's a new radio, I'm not familiar with it. I'm a little bit familiar with this one, but along the way you're going to learn stuff. And hey, oh, man alive, what's that? You don't like my speech? Along the way anyway, you have to allow in your process a chance to learn things. You see, that's time going by there, and that's what's happened here. So it's a problem with my YouTube channel. If you like, people might tune in, like you might tune into my YouTube channel to see how to do things. That's not quite what I'm showing you here. What I'm showing you is what happens in my shop. And you know, I'm sure these kinds of things happen to everybody, and I think if you're maybe not so vigilant, these, you might make mistakes like I'm making with this radio. Never even know it. Oh, Peanut. Well, yeah, you know what, Peanut? Hey, where are you going? Where are you going? Peanut. Come here. Poor guy, he wants some attention again. Okay, I have to go play with my cat. Usual morning routines. It's a gray, rainy day outside. They won't be going out at all today, I don't think. That's going to drive him batty. Okay, I think I'm going to have to call it quits here too at this point. And tomorrow I'll know what I'm doing for the first time. Hey, let's put it this way. I think I know what I'm doing now.